Hello friends, welcome to the Data Dictionary. In my previous classes, we learned what is central tendency, what is descriptive statistics, right? So we are going to discuss today what is standard deviation. Most of the people might be heard about the word called standard deviation, right? What is standard deviation? But most of the people will have confusion who are trying to read off this data science. They are not exactly known, not aware about what is this word, where we will use this. That is what we are going to discuss. So I'm not writing a definition, what is the standard deviation, but I will tell my explanation, my experience with my own books, because definition won't give a, yeah, we are not writing any exams, right? So definition is not the correct sentence to learn. I will tell. So deviation, standard deviation. So how much your data is getting spread means from the center. Center is what? Your mean. From the center, how much the deviation is happening. So according to my knowledge, how much the minimum standard, okay, how much the deviation is happening from the center. That is what I mean. How much the deviation is happening from the center. So if you take an example, let's say x equal to my random variable is x and the values are 1, 2, 3. The values are 1, 2, 3. Alright. So what is the average for these values? Average of, that means your mean. Sorry. This is your average. It means if I draw this data points here, how does this look like? This is how does it. So what does it mean? This is point number 1. Okay, let's take. This is point number 1. This is point number 2. This is point number 3. That is the mean. If you take the values, yeah, this is 1, this is 2, and this is 3. So out of these 3 data points, which one is the center? 2 is the center. Okay. So you are trying to calculate from the centered value how much the deviation is happening. From the centered value, how much the deviation is happening from the center. That's what we are doing. So this is, here we know it. The difference is 1 unit it contains from the center. But I want to see more practically, more formula kind of thing, because every scenario won't have the this kind of easy situation with the 3 data points. You may are going to cross with 30,000 data points going forward. In such cases, you are not going to draw the picture that which one is the center and how much it is happening. That's right. All right. So what I will do, yeah, first of all, I want to calculate how much the deviation is happening from the center. From the center. So what I am going to do, I am going to subtract my average values. I am going to subtract. So from each position, how much the distance is, how much the deviation is happening from the center. From each point, what is the difference from my average? Okay. So your average value is actually is 2 for all the data points. So I want to calculate x minus average. So how much the deviation is happening from the center? If you look out like this, 1 minus 2. Again 2 minus 2. Again 3 minus 2. So these are the deviations from the center. But when I want to calculate, so 3 different deviations. So I want to calculate what? Total deviations. Total number of deviations. So here total, you can write like this, total number of deviations. So, but what happened here? If I add up like this, or else instead of total, na, total may give some other meaning. What I will write is sum of deviations. I want to see the total deviations is how much, right? So what happens? If I add up these three things, this becomes what? 0. Right? If I add up all these three values, it becomes 0. That means the deviation is 0. What does it mean? There is no deviation. Zero deviation means there is no deviation. But actually, if you look at the points which I plotted here, I could see there is a deviation. There is a difference between one point to one point. But actually here I am getting the 0. That means something is wrong. What is the something is wrong? Because when I taken the original differences, when I am adding up all these differences, I am getting the 0. Why? Because plus or minus problem. So to overcome this situation, what I will do, I will make it square. I will make it square. Okay, I will let me write like this. Yeah. So x minus x bar, average is what? X bar. Okay, x minus x bar whole square. So what happens is minus 1 now? If I make it square, this one multiply with the same value, right? So minus 1 becomes plus 1, and remaining values also becomes this. So now if I take what is the sum of all my deviations, this is what my total deviations. Yeah. Now it is total 2 deviations. It means, yeah, we have the minimum deviation is 2. But I want to calculate, yeah, instead of total deviations, I want to have a standard value. That's what the standard deviation. I want to have a standard value to say how much the difference. This is total deviations. I want the minimum average standard value, average standard. So what I will do, so this is what I done. Let's go back here. What we have done here, first of all, you have calculated x minus x bar, right? X bar. So how do you write? Yes, x minus x bar. This is what we done. I should write xi. This is original. Okay, yeah, xi. So this is also small x, and this one is, yeah, bracket close. And what you done after that? You have taken the differences. That's what I did. This is what I wrote. And what after? I made it square, no? Yeah, let's make it square. So how you go to write square? It's 2. If you go here, I have an option to put up the square. Yeah. What happened? Yes. So I made it square here, and this is what? Summation, because you are adding up all these things now. You are adding the values now. So I make it summation. This is what we have done. So to calculate the average deviation, so what I will do, I will divide this total with n minus 1. N minus 1. So n is what here? Where n is the number of samples of your given data. So here, how many samples that we have taken? 3 values. 1, 2, 3. We have 3 values. So that means we are going to take 3 minus 1. Here also, yeah. So go back. So it is equal. So here the numerator value what we received? Numerator value we received as 2, and divided by 3 minus 1. 3 minus 1. So gives what? 2. So this is 1 we receive. That means your standard deviation is 1. So what I will do, to overlap this minus values, right? To overlap this minus values, we made it square earlier, right? To balance those things, what I will do, I will insert, yeah, a root. So how we are going to write the root? Just a minute. So like this. So initially I made it square to overlap that minus values. So now I made it square root to remove that square. So this becomes root 1 becomes again is 1. That means there is a one value of standard deviation that is happening from the center. That is what the mean. There is one value from the center it is happening, which is standard deviation. Clear as? Let's take another example. So in generally, in daily routine life, when you will use this word. So let's say, whenever your friend purchases a new bike, let's say, you will ask about what information, the most priority information is what? How much of the mileage is giving. Let's say, person says that, let's say he says that generally, I will get on an averages 42. On an averages 42. Sometimes, so he may says, is no, if you ask, is it daily you are getting 42 per liter? No, he won't say, no, not daily. Sometimes I may get 41, sometimes I may get 40, sometimes I may get 43, sometimes I may get 44, sometimes I get 42, sometimes 41, like this. This is what? This is the what he was happening. So daily he was taking 1 liter of petrol and he's making use of his bike and he's getting the average because of the, depends upon the roads conditions, how he was maintaining his bike, using the clutch and brake, all those things. So this is the question. Now if you ask you what is the on an average basis how much you are getting, so now he can ask like this. Now he can give us answer as, yeah, on an average my bike mileage is giving us 41.625. Now if you ask him again, is it exactly 41.625 you are getting every day? Definitely what you will say, no, not exactly 41.625, but always there will be a slight deviation will be there. They would understand this where we are using the word deviation, not exactly 41.6. There will be always some slight deviation will be there. So what does it mean? So the question is, how much the slight deviation that you are talking about? I want to have a perfect standard value. A perfect standard value to tell that what is the perfect slight deviation that you are talking about. So generally what the people will say, yeah, more or less plus or minus 1, plus or minus 2. This is the word that we will use, plus or minus 2. What does it mean? Either from the center, it can be plus 2 or minus 2. Similarly, here also we are using the same thing, standard deviation. Standard deviation is calculating those things only. Yes. So here I got the value as 1.40. That means sometimes I may get like this, 41 plus this value and 41 minus this way. What does it mean? Most of the scenarios, I am getting the mileage in between these two values only. Most of the scenarios, I am getting the mileage in between these two values. If you cross check it, most of the values will be between 40 to 43 only. If you look out, one or two values will be out of this region, but most of the values, that's what. Most of the values will be calculated with the help of average and standard deviation. That is what the usage. That is what the usage. So this is talking about what? Sample. But I can also calculate with these values only, with this descriptive statistics only, we can also calculate what? Inferential statistics. That is what we are going to discuss. So here, for this example, what I can write? Yeah, with the help of average and standard deviation, I can also explain about the variation of the data. Variation means here the difference. Variation of the or fluctuation of the data. I can also call it fluctuation. How much the fluctuation from the center it is happening. How much the fluctuation. So here actually what is our center? 41. Yeah, if I make it sorted, this one, no? Yeah, this is how, if I make it sorted, let's imagine. Yeah, from the center. How much of the fluctuation is happening from the center? Here also I said that how much of the fluctuation, deviation happening from the center. From the 41, some values are less than, some values are greater than. Hope this is clear. What is standard deviation? So what is standard deviation? This is what called. So then when we will call it as variance, what is variance? What is variance? It's variance. So here variance is when I don't use the square root na, for the same formula, when I don't use the square root for the same formula, that becomes variance. That means, yeah, the same story here. That's what. How much difference means what? How much the variance. This is your formula for variance. So if I make a square, it becomes standard deviation. If I don't square it, will be simply with the same value of variance. It will be simply with the same value of variance. If I make it square, then it becomes standard deviation. So in generally, notation wise, standard deviation will be called as, yes, in sample data. That means S is the terminology that we will use as standard deviation in sample data, whereas we will use, where is this max? Yes. Most of the people like me, you might be seeing this kind of thing. Yeah. This is the thing which we'll use for what? Yeah, for population standard deviation. So for population standard deviation, we'll use this one. All right. So S is for sample data, and sigma. This is what sigma will call as sigma. Sigma is for population standard deviation, rotation. Okay. Similarly, and the I mean the relationship. Yeah, relationship. I said this is variance. Let me write here first of all. This becomes variance. Okay, and the relationship between my standard deviation and variance. How we are going to write? Yeah, variance of variance. Variance is equal to sigma square. Sigma square. So instead of writing like this, I'll write like this because notation wise will be the better looks. Nice. Clear, guys? So how we are going to the relationship between what is variance and its standard deviation? Hope you understood my session clearly. So whatever the questions or doubts, if anything that you have, still you can just approach me any moment. Please, please subscribe it, like it, and make your friends to subscribe it so that they can also will have the advantage of understanding the data science classes with purely statistical basis from beginning itself. Please ask your friends to subscribe as well so that I can get some more encouraged and I can upload some more videos to related to my data science classes. Thank you.